I started out as a student working at the second NAMRC in Madison a long time ago when I was a graduate student. And then we'll talk about a few other things. So first, this is a slide that I got from Don Luca. It talks about your career as a professional. You can see the age on the bottom. And so what I thought I would do, so I don't drink, so the research maybe stretched a little bit more into the traveling, but I'm definitely into the storytelling part. So I thought I'd lay out my career at NAMRC on this slide. So first of all, before 25, you essentially work at NAMRC as a grad student, right? All of you in the green shirts are understanding it. Then you start presenting papers. Then you start presenting papers and you start organizing and chairing sessions, although I appreciate there's a lot of young folks here are doing that. Then you just attend, and then you give the founders day. That kind of sums it up. So it's a great career. So, okay. The first one you know was at Hamilton Master University, George Scott Smith knows, but there's many other folks who remember Professor Clusty. The second one was at Madison. I worked there as a student. We didn't wear, I guess we wore red shirts at the time because Madison is red. No, I can't wear red because that's Stanford, and that's not good. I remember Professor Clusty took the place of someone who unfortunately couldn't attend the conference and presented his paper for him. And in those days, there was a lot of kind of blunt, candid conversation. And Clusty, rather than simply presenting the transparencies, because we didn't have slides, because we didn't have computers in those days, back in the, through snow up to here on the way to school, Clusty completely tore the paper apart and said, here's what he should have said. So be careful when you ask someone to present your paper. And this is what one of the pictures taken. This is Soropi Kalpachin, right? Looking skeptically at something that Sam Wu is talking about. I don't know who the other two gentlemen were. And about that time, this is what I looked like. I'll be the one on the left. And as a graduate student when I finished up. Okay, so I think someone mentioned early on that Sam is responsible for about 25%, something like that, or his family, the academics working in the U.S. today, or around the world actually. So I was number 29. One of these, Dick DeVore, you'll recognize the string. John Sutherland is his student, and Margot, who just got one of the Outstanding Young Manufacturing Engineering Awards, was John's student. So I mean, the Wu family kind of extends throughout the entire area. There's a lot more we can't even add. Shiv Kapoor, Juni, Jack Hu, all kinds of other folks. You can go online and see this long, impressive list of folks that worked with Sam. And Sam certainly gave us the spirit of manufacturing, made manufacturing and the involvement in NAMRC to be a legitimate profession, right? Something you could be proud of and say, I'm happy to say I'm a manufacturing engineer, and many of us went on to have careers in manufacturing. Okay, the 27th NAMRC in Berkeley, Klaus Weinman called it an outlier because it was not in the central part of the United States. Now Klaus, as you may know, was from Michigan Tech. That's not in the central part of the United States either. I mean, that's way up, that's almost Canada. Except for the Civil War, that was supposed to be part of Wisconsin. The troops ended up marching south rather than marching north to boot the Michiganians out of there. Anyway, so Berkeley was in 27. I don't think it's been back, but now Barbara Linka is at Davis. Barbara Linka should be hosting NAMRC and her colleagues anytime soon now, so ask her about that after lunch. At Berkeley, we put this in the call for papers. So this was NAMRC 27 XXVII. NAMRC 30 was NAMRC XXX. There was a little difference in attendance at that crowd, but it was still very technically oriented. And if you look at the list of things, these pretty much apply today, right? I mean, maybe we have this argument that there aren't as many industry folks or national lab folks that are involved, but it certainly is something that's very interesting, and I think that's what makes NAMRC, and now the connection with MSEC, very vital. The fact that there's 500 some folks attending the conference, when in the old days, like Berkeley's NAMRC 27, I think was probably about 150, 160 at tops. And Larry was telling me the number of papers that were submitted to the proceedings, so it's amazing success. Okay, so So just a little bit of introspection on this. This is a paper, some of you know from Francesco Giovanni, that talks a little bit about the evolution of things from very early days of manufacturing. So NAMRC certainly wasn't back when Henry Ford and F.W. Taylor involved in the improvement of mass automation, but it shows these kind of big changes that occur from stage to stage. And if you think about what really drove it, at each stage someone recognized that there was some money or time or resources being left on the table because of inefficiencies, pulled them out, made efficiency improvements or made optimizations or changes, CNC, automated tooling, lean manufacturing, better use of quality issues, et cetera, et cetera. And the last one that Giovanni talks about is the change to sustainable manufacturing. Now, Giovanni wrote this before things like big data, digital manufacturing, even additive manufacturing at this time was just kind of only applied to certain specific areas. So I thought it might be interesting just to talk a little bit about where we think what's coming is next, right? So you might add, if you're going to actually do this last step, sustainable manufacturing, there's a lot of work to be done, and it's great to see a number of sessions at the conference this year that are talking about that. But really to include all three pillars, the societal aspect, economic and environmental aspect, are really important. There's a lot of work that's left to be done there. All the work relating to additive manufacturing, of course. I mean, this is not simple. Dean is sitting here. Ralph Resnick was going to be on the program. We talked a little bit about that. You see the challenges that are associated. Things related to digital or cyber manufacturing, cybersecurity issues, kind of data transparency, control of data, et cetera, verification of it. Things related to scale up and legacy new systems for things like interoperability. We just saw the award to MT Connect, one of these kind of things that helps to drive that tremendously, that makes the digital enterprise much more successful. And this is not an exhaustive look, but then kind of cloud manufacturing, whatever that actually means in practice. I mean, it's a great marketing phrase, but we all know that the little connections are there. So then you ask, what are the processes, right? I mean, NAMRC's been working on processes. Originally it was forging, cutting, and grinding, right? Because it mimicked syrup stuff for 43 years. So where are the processes? Well, they're actually at the bottom of all this, right? None of this stuff works at the top. All the connectivity and the big data and the digital this and the digital that, none of it works unless you understand the process technology, right? So if you think a little bit about a factory, and you do kind of a Google Earth view of a factory, starting at the highest level of an enterprise, and zooming to a facility, and then to a line, and then to a machine, and then to tooling, and then to the process, you realize there's lots of different scales, right? Data occurs at all kinds of different rates. Microseconds or nanoseconds at the process level, weeks and months at the enterprise level. So there's information flowing, activities at all different levels, different rates, different degrees of resolution, different actions in response to it, and all of those things are important. So depending on where you look at the process, you can focus in on any one of those. Then if you think about what we're trying to accomplish on the other side in terms of optimization, there's the lowest end, there's tool condition monitoring that people have been working on for many, many years, right? Automation, everybody says the robot's going to be the greatest thing since sliced bread. It still is the greatest thing since sliced bread, but still there are lots of issues associated with that, social not the least of which. Safety, availability, cost of ownership, sustainability at the top end. So lots of opportunities all along these, but they all sort of depend upon understanding down at this level. So a couple of years ago, this is an eye chart, but if anybody wants this, we can send it. We put together a chart that kind of talked about this path. And it all starts with modeling at the very basic level of the process. You can take the cutting tool and put in welding or additive or forging or grinding or whatever. But if you have a decent model or a decent understanding, then you can build on top of it. You use sensors to provide feedback and validate, but you can build all of this stuff in, getting from process mechanics to more and more digital and information mechanics, if you will, until you get to an operation where you can't do something like first part correct, right, production. But you got a whole list of criteria, some of which are absolutely requirement for manufacturing engineers as in the old days, but some are now becoming more and more complicated because of the layering of digital technologies and information on top of it. And the interoperability that MT Connect, for example, and others are dealing with allows these things to communicate at different levels. But there's a lot of work, but it all starts with the process. So NAMRC is still very significant, very fundamental to the work we're doing, and in fact, the better resolution you have at this level, the better the stuff at the higher level works. So then we should really think also honestly about what we're doing and how we're doing it, how efficiently we're doing it, how efficiently we're creating products out of resources. The aerospace industry uses this thing called a buy-to-fly ratio. How much comes into the factory, how much actually goes out on the aircraft, and sometimes it's precious little. In fact, the only two real charts, this is something from a guy named Julian Allwood. If you sort of plot for a process from the melt, liquid material back through a series of process stages, and you have the yield, meaning how much comes out of the next process step versus what came in, and what's the cumulative process energy. It's a little frightening. Here's three examples. This is an aircraft wing skin panel, so you're down into almost single digits of yield. This is an aluminum beverage can, so you're about 40-some%. Here's a car door panel. This is not because people are wasteful and inefficient in the sense of normal process technology and being sloppy. It's because the technology doesn't allow us to do it any better. Everybody says, okay, fine, but you can recycle aluminum, but you can't recycle the energy or all the effort and the time that's been spent. So this is exactly where NAMRC comes into the picture. How do you convert from this stage to a car door panel and save 10 or 12 more % in yield? The energy that's saved in that would completely outweigh a lot of the stuff that we're doing these days in other sort of domains. We have a number of knobs we can play, right? And the big knob is this kind of improving manufacturing technology, how you can convert resources using energy and materials into a finished product with higher yield, but maintain the higher throughput and keep the costs under control. Last thing. There are times when you can say, well, maybe manufacturing doesn't use that much energy in the big picture, like in the automotive industry. Maybe it's 10% of automotive impact over the life cycle of a vehicle is due to the manufacturing side. 90% is due to the usage. You're burning fuel, you're using tires. Fuel takes energy to create, et cetera, et cetera. Here's an example of how manufacturing addresses that. So these are some data that I got from a friend of ours that works at Daimler on the improvement in fuel efficiency, fuel economy in diesel engines due to things like higher injection pressures, better tolerances, better thermal coatings, etc. In fact, what it is really increase in performance due to tolerance and precision from manufacturing processes. I mean, there's a bit of design of the engine in there as well, of course, but the manufacturing process capability has increased to allow them to tout a factor of 4 improvement in the fuel economy. So that completely blows the case wide open in terms of saving over the life cycle of the vehicle. I mean, there's a lot of life left in the internal combustion engine, and Elon Musk notwithstanding. So, and it's an embedded, it's an understood technology, it's amortized cost in many cases, so we shouldn't throw it out, and you can do very, 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 very well. So we call this leveraging, and this is what those of us in this room are doing, right? You start out with some little improvement in manufacturing, which seems little over the life cycle of the product. You find out that that improves the product performance a substantial portion. That has savings in the case of automotive, say fuel savings, and then you get all these other benefits, environmental benefits. It reduces water use, it reduces greenhouse gas, air pollution, particulates, etc. So for a little bit of smart manufacturing on one end, you get a huge big bang for the buck in terms of environmental impact, and it's those kinds of little pieces that are going to have to add up together to make manufacturing more sustainable in the future. And then, last but not least, manufacturing and organizations like NAMRC play a very important role in going from this linear economy to a circular economy. How we actually connect the outputs at different stages of consumption back to the user or the producer, remanufacturing, all of the things you hear, some of which, but are really, these are really manufacturing challenges. Take things apart, reconfigure things, do other kinds of things. Most of the folks working this don't have a clue how to actually make this work because they're not manufacturing engineers. So we have to make sure they understand what's important about that. So the future is bright for manufacturing engineers, even when President Obama leaves office, and who knows what happens next. We understand it's important. We see the role we have to play. As you get a little bit more senior and you're through with your tenure and all kinds of other stuff that you have to jump over to get up to where you can actually do what you want to do, you can think a little bit about these kinds of challenges. So I think, you know, in another 20, 30 years when NAMRC is still banging away, you'll see some of these things have been solved, but there'll be new issues. And with that, I thank you very much.